You've seen it 100 times. A ship drifts too close. An invisible mouth opens in space, and everything the ship, the light, the screaming gets pulled in, sucked down the drain of the universe. It's a great scene. It's also wrong. Nothing in this universe sucks. Not a vacuum cleaner, not a drain, and not a black hole. Stay with me for 20 minutes. And by the end, you'll be able to look at the scariest object in the sky and say, in one honest sentence, what it actually does. Not devours, not sucks, falls. And so do you right now, sitting in your chair, receipts on screen. Real photographs of real black holes taken by a telescope the size of the Earth. The names of the scientists who won a Nobel Prize for watching stars do the thing I'm about to show you. And one thought experiment, straight from NASA, that breaks the movie version in a single move. Here's the line we're going to cross tonight, and most channels never do. They tell you a black hole is a monster that grabs. I'm going to show you it's a place where falling never stops, and that the difference between grab and fall is the whole secret of gravity itself. Let's start by killing the vacuum cleaner. Here's a thought experiment. It sounds like a trick. It isn't, it's the standard one physicists use, and NASA spells it out on their own education site. Take our sun. Right now, it's a ball of glowing gas about 1.5 million kilometers across roughly 360 miles. Now imagine you could crush it, not remove it, not add a single gram. Just compress all of that mass down until it became a black hole. How small would it have to get? About 3 kilometers across the middle, under 2 miles. The entire sun squeezed into something that would fit inside a city. Now here's the question that matters. What happens to Earth? Most people say, we get pulled in, we get sucked down, game over. Wrong. Earth keeps orbiting, exactly as it does today. Same path, same year, same speed. Nothing about our orbit changes at all. Think about that for a second, because it's the whole video in one fact. We replaced the sun with the scariest object in the universe, and Earth didn't even flinch. Why? Because gravity doesn't care what something looks like. It only cares about two things: how much mass is there, and how far away you are. We didn't change the mass, same sun, just compressed. We didn't change the distance, Earth stays put. So the pull stays identical, down to the decimal. The black hole has no extra suck. There's no special vacuum mode. It is exactly as gravitationally pushy as the sun it replaced, and not one bit more. What we just unlocked. A black hole is not a cosmic vacuum cleaner. Swap the sun for a black hole of equal mass and Earth's orbit doesn't change. The horror only starts if you fall very, very close. Source on screen, NASA, imagine the universe. So if it's not sucking us in, what is it actually doing? To answer that, we have to ask a question you probably haven't asked since you were a kid. And the honest answer is stranger than the movie. What is gravity, really? Let's give school its fair hearing first. Your textbook isn't wrong. It taught you Newton. Every mass pulls on every other mass with a force. Drop an apple, the Earth pulls it down. That equation has flown spacecraft to Pluto. It works. But here's the part school skipped. Newton himself didn't believe his own picture. He wrote that the idea of one object reaching across empty space to pull another with nothing in between was so absurd that no thinking person could accept it. His own words. He had the math. He admitted he didn't have the mechanism. The mechanism took another 230 years and a man named Einstein. And what Einstein found is this. Gravity is not a force that pulls. Gravity is the shape of space and time. Let me show you what that means, because it's the hinge the whole night turns on. Picture a trampoline, stretched flat. Now roll a bowling ball into the middle. The surface sags, it curves down toward the ball. Now flick a marble across the trampoline. It doesn't go straight. It curves toward the bowling ball. It might even circle it for a while before spiraling in. Did the bowling ball reach out and grab the marble? No, it never touched it. All the bowling ball did was bend the surface. The marble was just rolling in the straightest line it could across a surface that was no longer flat. That's gravity. Mass bends the space around it. And everything else, planets, light, you just travels in the straightest line available, through space that's been bent. This is the most important sentence in the video, so I'm going to say it slowly. In Einstein's universe, a falling object feels no force at all. None. It isn't being pulled. It's coasting, moving in a perfectly straight line through a space that's curved. Physicists have a name for the straightest possible line through curved space. They call it a geodesic. And an object following one is in what's called free fall. Bookmark that word, free fall. We're coming back to it, because it's about to do something beautiful. Here's the test that proves it's true, not just a nice story. When you're in free fall, really falling, no air, no ground, you feel weightless. Ask any astronaut. The International Space Station isn't weightless because it escaped Earth's gravity. Earth's gravity up there is almost as strong as it is on the ground. The astronauts float because they're falling, constantly, around the curve of the Earth, missing it, forever. Free fall feels like floating because, in Einstein's universe, falling is the natural state. It's standing still on the ground that takes a force the floor, shoving up on your feet right now. Feel that? That push from your chair? That's the only gravitational force you've ever actually felt. And it points up. What we just unlocked, gravity isn't a pull. Mass curves space-time and everything coasts along the straightest line through the curve. Falling isn't a force acting on you, it's the absence of one. Source on screen. General relativity. Einstein matngin chincham free fall as geodesic motion. So now we can finally ask the real question. If everything just coasts along the curve, what is a black hole? And the answer is almost funny in how simple it is. A black hole is just a place where the curve got so steep that every straight line points inward. That's it. That's the answer. Take that trampoline again. A planet makes a gentle dip. A star. A deeper one. Now imagine piling so much mass into so small a space that the dip becomes a funnel, with walls so steep that, past a certain edge, there is no straight line that comes back out. Every direction you could possibly travel leads further down. That edge has a name, the event horizon. And here's the thing nobody tells you. It isn't a wall. It isn't a surface. There's nothing there to touch. It's just the line beyond which every road leads in. Cross it, and to leave, you'd have to travel faster than the one thing the universe won't let you beat: light. How big is that edge? We already met the number. For a black hole the mass of our sun, it's about 3 kilometers across, under 2 miles. There's even a clean formula for it, worked out by Schwarzschild in matngin chincham while he was serving on the Russian front in World War I. He did the math in a trench and mailed it to Einstein. He died a few months later. The formula carries his name, the Schwarzschild radius, and it scales perfectly with mass. Want to know how small you'd have to crush anything to make it a black hole? For the sun, 3 kilometers. For the Earth, 9 millimeters. Smaller than a grape, about 1/3 of an inch. For you, standing there, smaller than a single proton. Everything has a Schwarzschild radius. It's just that, for almost everything, it's buried trillions of times deeper than the object actually goes. The Earth's 9-millimeter horizon sits at the dead center of the planet, with 6,000 kilometers of rock on top of it. So it's not a black hole, it's just rock. A black hole is what you get when an object finally falls inside its own Schwarzschild radius. When a giant star runs out of fuel and collapses, nothing left can hold it up and it falls. Past 3 kilometers. Past 1. Past everything. Until the straightest line, it could possibly travel curves back on itself. So even the black hole itself didn't get sucked into existence. It fell into existence. Falling all the way down. Same word, every time. What we just unlocked. A black hole is a region where space-time is curved so steeply that every path, even light's, leads inward. The event horizon isn't a wall, it's the edge past which there's no way out. Sun's horizon, ba kilo met. Earth's, chin mili met. Source on screen. Schwarzschild radius, r hig macta quard. Schwarzschild matngin chincham wisao. Now, you might be thinking this is a lovely story, but how would anyone ever know? You can't photograph the dark. So before we go one step further, I owe you the receipts. Because this is exactly where most channels handwave, and we don't. Here is how we know black holes are real and that they fall instead of suck. 2 pieces of evidence. Both photographed, both checkable tonight. First, the stars. At the center of our galaxy, 27,000 light-years away, there's a patch of sky called Sagittarius A star. For almost 30 years, 2 teams, one led by Reinhard Genzel in Germany, one by Andrea Ghez in California, pointed the world's biggest telescopes at it and did something painstaking. They watched individual stars, night after night, year after year, and tracked exactly where they moved. What they found is breathtaking. The stars near that spot are whipping around something invisible. One star in particular, they call it Shy, completes a full orbit in about 16 years. A whole star, looping around an empty-looking point, on a long stretched-out ellipse, moving at a few percent of the speed of light at its closest pass. Now watch what those stars are doing. They are not getting sucked in. They are orbiting, round and round, for decades, stable as clockwork, exactly like Earth around the sun, exactly like the marble circling the bowling ball on the trampoline. They're falling around it. Forever, in free fall. The only way to get that much mass, about 4 million times the mass of our sun, into a space that's small, with stars calmly orbiting outside it, is a black hole. Genzel and Ghez won the Nobel Prize in Physics for this in Heinginle Haimue, shared with Roger Penrose. Not for a theory, for 3 decades of watching stars fall in circles. Second, the photographs. In April 2019, a project called the Event Horizon Telescope did something that sounds impossible. They linked radio dishes on 5 continents into a single instrument effectively the size of the entire planet, and they took a picture of a black hole in a galaxy called MTM, Muibai 55 million light-years away, 6.5 billion times the mass of our sun. The image is a ring of light wrapped around a dark center. That dark center is the shadow of the event horizon. The first photograph in human history of the edge of no return. Then, in May 2022, the same team turned the Earth-sized telescope on our own galaxy's center on Sagittarius A star itself, the exact object those stars had been orbiting for 30 years. And there it was, a second ring, a second shadow. The monster at the heart of the Milky Way, sitting quietly, exactly where the falling stars said it would be. Notice what's in that picture. A ring of glowing gas, orbiting. Not a whirlpool yanking everything down, a stable, bright ring of material in orbit, just outside the edge, falling around it. The photograph itself shows you black holes don't suck. They host the most stable orbits in the universe, right up until the very last edge. What we just unlocked, we have watched stars orbit a black hole for 30 years, and we have 2 photographs of the event horizon's shadow. The evidence doesn't show a vacuum cleaner. It shows orbits falling, stable, lawful. Sources on screen. Genzel, Ghez, Nobel Prize in Physics, Heinginle Haimue. Event Horizon Telescope. Matmoi by April Heinginle Mui Chin and Skra A. May Heinginle Haimui Hai. So black holes are real, and the things near them fall in orbits, not down a drain. Which leaves the question everyone actually wants answered. What if you cross the edge? What happens if you fall in? Here's where I have to be honest with you in a way the movies never are. Falling into a black hole would absolutely kill you, but not by sucking, by stretching. And the reason is the same geometry we've been talking about all along. Picture falling in feet first. Your feet are a little closer to the center than your head. And because the curve of space gets steeper the closer you get, the pull on your feet is stronger than the pull on your head. Not because anything is grabbing your feet, but because your feet are following a steeper part of the curve than your head is. The 2 ends of you are trying to fall along slightly different lines. So you stretch. Physicists have a name for this, and it's the only genuinely silly term in all of physics. They call it spaghettification. You'd be drawn out into a long, thin strand, like pasta, as the difference in the fall between your feet and your head grows without limit. But here's the subtle part, and it's pure geometry. That stretching isn't suction, it's a difference. It's the same physics that makes the ocean tides. The moon pulls a little harder on the side of Earth facing it than on the far side, and that difference, that gradient, lifts the seas into 2 bulges. Spaghettification is just that, turned up to infinity. A tidal force, not a grab. A difference between 2 falls. And now the punchline that breaks the movie completely. The bigger the black hole, the gentler the stretch. For a small black hole, say, a few times the mass of the sun, the difference between your head and your feet near the edge is so violent it would tear you apart long before you arrived. But for a truly giant one, like the 4 million sun monster at our galaxy's center, the curve is so broad and smooth that you could cross the event horizon, the point of no return, and feel nothing. No wall, no jolt, no drain. You'd sail across the edge of the universe's most famous one-way door without noticing the moment you passed it. You wouldn't be sucked in. You'd fall in, weightless. Coasting in a straight line. Exactly as you'd feel jumping off a diving board right up until the curve closed behind you. And every direction, including the way you came, pointed deeper in. Even the future itself would now point toward the center. There would simply be no road back out, the same way there's no road back to yesterday. What we just unlocked. A black hole doesn't kill by sucking it, kills by stretching. The difference between 2 falls, the same physics as ocean tides. and the biggest ones let you cross the edge feeling nothing at all. Source on screen. Tidal forces spaghettification. Tidal force scales inversely with black hole mass. So let's put the whole thing back together. Because once you see it, you can't unsee it. A black hole does not suck. The word is wrong, and now you know exactly why. Gravity was never a pull. It's the shape of space, bent by mass, and everything planets, light, stars. You just coasts along the straightest line that shape allows. A black hole is simply the place where that shape got so steep that every straight line bends inward. The event horizon isn't a mouth. It's a horizon the edge past which out stops existing. Swap our sun for a black hole of the same mass, and Earth orbits on, undisturbed because there was never any extra suck to fear. The stars at the center of our galaxy have been falling in calm, stable orbits for the entire time humans have been watching, and we have the Nobel Prize and 2 Earth-sized photographs to prove it. You are doing the same thing those stars are doing, right now. You are falling around the center of the galaxy at over 500,000 miles an hour, about 820,000 kilometers an hour, and you don't feel a thing. Because falling, in this universe, is what feels like nothing. It's the chair under you, pushing up, that you feel. The only force in the room is the one stopping you from falling. You are not being pulled through your life by gravity. You are coasting through a universe that bends beneath you. And so is everything else all the way down to the dark, falling stars at the edge of forever. That's the beauty of physics, not comfort. Not the monster from the movie. Truth. And in Hangin Ler Sao, with 2 photographs and a Nobel Prize proof. So let me ask you something, and there's no wrong answer. Before tonight, what did you picture when you heard black hole? A drain? A mouth? A vacuum cleaner in space? Sit with the picture you used to carry and notice how it just changed. Tell me in the comments, what's the one word you'd use now instead of suck? Just one word. I read every reply, and I want to see what sticks for you. If this gave you a new way to see the sky if they fall, they don't suck. Rearrange something in your head, subscribe to the Physics Storyteller. No paywall, no hype, just physics with the receipts on screen every single time. And next time on the Physics Storyteller, we go after another thing the movies got backwards. Spin. Electrons spin, the planets spin, the whole universe seems to spin, and yet, when you look closely, nothing is actually spinning at all. I'll show you what that word really means. Until then, look, everything you see up there is falling, including you. There is no suck, there is only the curve.